So if we're going to differentiate this 2 to the power of x, it is going to be 2 to the power of x line 2. This one over here, we have to do it explicitly. So we write it as we're actually doing dx by dy, and then we have to times it by dy by dx. So hopefully you understand that. Equals this. So we now have to differentiate the right-hand side. So let's just focus on xy. We could use the product rule over there, where you could write u as x, du by dx is just going to be the number 1. And then this y is going to be the letter y. And then dv by dx is just dy by dx. So if you apply this product rule, you got x times by dy by dx, and you got y times by the number 1. But don't forget that there was a number 2 in front, so you put a squeeze in the 2 there, and I'll squeeze in the 2 right over there also. Now, they tell us what the x and y value is. X is 3, y is the number 2, so we just have to substitute these numbers in. So substituting it in, we get this. I'm going to move this to the other side, so we get 2 dy by dx, and we move the number 4 to this side over here. 8 line 2 minus 4. Then we divide everything by the number 2, and that is the actual gradient. So I'm going to try differentiate this over there. All right, minus sine 2x. The derivative of 2x is the number 2, so we squeeze in the number 2 over here. And then we've got to differentiate cos 3y. So I'm just going to write minus sine 3y. Now we have to differentiate the 3y minus 3y basically. So I'll squeeze in minus sign over there. And to differentiate that, it's just going to be number 3, but you also have to do it explicitly. So you write dy by dx like so. And this is all equal to the number 0 when you derive that. So we'll move the dy by dx to the other side. So we get something that looks like this. And then we'll divide by 3 on that side and divide by sine 3y on that side. And that is the final answer that we get. Now they're saying that x is equal to pi over 6. So we substitute pi over 6 into this. Sorry, they say find the value of y. Okay, so we'll use this equation, the first equation over there, and we'll put pi over 6 into that equation. And we get something that looks like so. And then what we do, we move this to the other side, which is equal to this. And then we just do cos minus 1 of the half, which is pi over 3, which is what 3y is equal to. So y is equal to pi over 9 when you divide by the number 3. So then they say find out the equation for the tangent. So we have dy by dx, and we have what x is equal and y is equal. So we just have to substitute this into that, and we substitute that into that, and we get minus 2 over 3 as the gradient. So then what we have to do, y minus y1 is equal to m, which is in this case minus 2 over 3 times x minus pi over 6. Close the brackets. We multiply it all out, and we get y equals minus 2 over 3 x plus 2 pi over 9. But we want it in this form over there where they are integers. So to get rid of divide by 9, we times by 9, and we'll times everything by 9. And that will even turn that into an integer. And we get something that looks like this, and then we move it all onto the left-hand side. And that is our... So I'll try question number 3. We'll try this side, and we'll make our u equal to y, and my v equals to e minus 2x. We do the product rule, which you see over there. So du by dx will differentiate with respect to y, so that's 1, but we put the dy by dx over there. And when we differentiate this, the derivative of minus 2x is minus 2. So we've got minus 2 e to the power of minus 2x. And then we just plug it in. Now what so this is the answer down there. Now what we have to do is differentiate the right-hand side. 2x is just going to be 2. This is just going to be 2 dy by x. Now, we put all of the dy by dx on one side. So I'm going to move this to the left-hand side, and everything else goes on to the right-hand side. Now, I want to make something clear. This is actually 2y. This is minus 2y, but because I brought it to the other side, it'll become positive. And we just have to factorize by dy by dx over here. And we make dy by dx the subject, so we divide by this on the other side. And this ends up being our answer. So question number B is they give us the x values, they give us a y value. So what we can find out, we got the dy by dx equation right over on the right-hand side. So we just plug the numbers in to find out what dy by dx is equal to. So that is the calculation, which is equal to minus 4. So the tangent has a gradient of minus 4. But they're talking about a normal. So we take the gradient, minus 4, and we do minus 1 divided by the gradient. So the normal has a gradient of a quarter. We then do y minus y1. y1 is 1 is equal to m, which is the gradient, times by x minus x1. Now, x1 is just the number 0. So we just tidy this all up a little bit and move the minus 1 to the other side. Times everything by the number 4 and move it all onto the left-hand side. No, actually, we'll move this. So what we're going to do, times it all by the number 4. So we got x plus, this will be 4y, but moving it to the other side is minus 4y. Timesing this by 4 is plus 4 equals to 0. So I'm going to try question number 4. And I'm going to differentiate y squared, which is just going to be 2y. And this is going to be explicit. So we're going to write dy by dx. We differentiate this, which is minus 3. Again, explicitly. So we write dy by dx right next to it. And this is just going to be 3x squared. And then we rearrange it to put the dy by dx on one side, which it already is. We just need to factorize it by dy by dx, which is equal to that. And then just bring the 2y minus 3 on the other side by dividing it over. And this is what we get. Find out the gradient when the y coordinate is the number 3. Well, we need to find out what the x coordinate is. So we'll use this equation right there, and we'll substitute the number 3 wherever the y is. So we get something that looks like that. So x cubed, if you rearrange it, is equal to minus 8. So x is equal to minus 2. All right. So we now got x and we got y, and we could plug in the y over there, and we could plug in the x over there. We do this calculation and we get the number 4. So I'm going to do question number 5 now, and we're going to, we're told that the gradient is 8 over 3. So we're going to differentiate all of this. So this is 6x. Do that one, which is minus 2y dy by dx plus xy. Now, xy, we have to use the product rule. So the product rule is shown on over here. So we're going to say that u is equal to x, b is equal to just a y. If I do dv by dx, I just write dy by dx, and du by dx is just going to be the number 1, and then I just plug this in. So if I do u times by this, and then I do v times by this over here, equals the number 4, which when you differentiate is 0. So you factorize by dy by dx, or actually what you could do, you know what dy by dx is 8 over 3. So you substitute 8 over 3 there, you substitute 8 over 3 over there. So you get something that looks like this, and if you tidy it up, you get this. Then you multiply everything by the number 3, and you get something that looks like that. Tidy this all up a little bit more. 6x minus 13y is equal to the number 0. And we could find out what y is by just doing that calculation. So y is equal to 2x. And that is the whatever. You just could move the 2x to the other side. So let's see for question B where these two lines meet up. We got y is equal to 2x. So we could just substitute it all into over here. So we get something that looks like that. Tidying this all up a little bit more. X squared is equal to 4. Just square root it. X is equal to 2, or it is equal to the minus 2. Find the coordinates of the 2 points where x is equal to -8. So they want you to find out the y coordinate. So to do that, you go back to this thing, and then you're putting x is equal to -8 into that and that. So we get something that looks like this. You move it all over, divide by -4 also, and you should get y squared minus 24 y plus 128. Okay, then you factorize this, and then y is equal to 8 and 16. Then you could find out your you find out your x, your x coordinate on those points is -8. So you write down the x, and you just write down the 2 different y coordinates. And that is your thing. Find out the gradient of these points. So you have to differentiate explicitly. So let me try differentiate this. It's going to be 3x squared. Differentiate that, which is 8y dy by dx. And just use the product rule for this. So I'll take the 12 out, and then I'll do the product rule for x and y. I'll put u as x, and I'll put v as y, and I'll apply this rule. So this one is just going to be dy by dx if I did dv by dx, and du by dx is just going to be number 1. So if I substitute it in and times it by the number 12, okay, that's important, I get this. And then what I want to do is I want to move my this to that side and move my 12y to this side. And now factorize by d, and this is what I get. And then I make dy by dx the subject. And then you got to find out the gradient at each of these points. So what you're going to do, you're going to take this equation and you're going to substitute the 2 coordinates into it. So these are the 2 coordinates over here. Okay. So I'll plug in -8 as my x coordinate right over there and right over there. And then I'll plug in my 8 over there and my y coordinate 8 over there. And what I get is I get the answer as -3. Now, if I do the same, but this time I switch the x coordinate to -8, which is the same as before, but I put my y coordinate as 16, and I use this equation right over there, I get 0. So it is basically a horizontal line at this point, but there's a negative gradient at this point over there. So I'll try question number 7. And to differentiate this, so to differentiate the sign x is just going to become x, and the differential of the cos is actually minus sine y. And because we're doing it explicitly, we have to write dy by x like so. And to derive that is just the number 0. So we move this to the other side, and we try and make dy by dx the subject by dividing both sides by sine y. And that ends up being my answer. Question number B. Find out when this is equal to 0. So dy by dx is equal to the number 0. Now, the only thing that could be equal to 0 is the cos x. So we just do cos -1 of 0, and that gives us x as equaling pi over 2, and x is equal to minus pi over 2. So you need to find out the y coordinate. So we go back to this equation right over here. But we could just rearrange it. Cos y is equal to 0.5 minus sine x, like so. We could even go as y is cos -1 of all of this. So I've written out like that. And we got two of them. So we could put pi over 2 into this. And if we put pi over 2 into that equation, what we get is cos y should be equal to -1/2. And because it's equal to -1/2, there's we do cos -1 of that. And y is 2 pi over 3 or -2 pi over 3. And both of these are valid for that range over there. So we write pi, 2 pi over 3, and pi over 2 minus 2 pi over 3. So those are 2 coordinates. And we do case number 2. Case number 2 is this time we substitute -1/2 into it. And that will make cos y equals 3 over 2. You can't do cos -1 of 1.5. So the only 2 answers are those. So what we'll do, we'll derive this, which is just going to be 6x. We derive this, which is only going to be dy by dx. The derivative of this, which is -2. Apologies, I should have done question 8. I accidentally went to the wrong question, which is why I was a little confused. So I'm just going to do question 8, and then question 9 is this, but this is going to be -4y by dx. The derivative of that is just +2. The derivative of that is -3y by dx. And this derived is just going to be 0 at the end of it. So we're going to substitute the number 0 as x over here, and we're going to put the number 1 as y over there. So we get something that looks like that. Now this and this makes -7 dy by dx plus 2 equals to 0, and rearrange this to make dy by dx the subject, which it becomes -7 over 2. Sorry, it becomes actually 2 over 7, okay? But because we're looking for the normal, we just do -1 divided by 2 over 7 over there, and we get -7 over 2, and that is our gradient. So let's solve question 10. So we have to derive 3x squared. So that will become 6x. We got to differentiate that, which will become 8y, and then we just put in dy by dx because we're differentiating it explicitly. This is just -2, and then we got +6. So I'm going to write +6, and then we got to differentiate x and y. So I'll put u as x, I got to put this as y. Y times by this, you write y. That times by that, you put x dy by dx. 6 times that, 6 times that, you get that. And this is just going to be equal to the number 0. And then what I would try and do is make dy by dx the subject. So I'll factorize this, I'll factorize that, and I'll move all of this onto the right-hand side. So it will become +2 minus 6y minus 6x, and it will look like that. And then we just want dy by dx by itself, so we're going to divide by all of this. So that is what we get. Now we need to find out the gradient at this coordinates over there. So my x coordinate is 1, so I'll plug in 1 over there, and my y coordinate is 2, and I'll plug in 2 right over there. So I get something that looks like that. So dy by dx ends up equaling -4 over 5. And then what I'll do is apply this equation where my gradient is -4 over 5. My x coordinate over there is -1, and my y coordinate over there is -2. So -2 is actually +2. So you times everything by 5, you rearrange everything, and what you should get is 4x plus 5y plus 6 equals the number 0. Find out at the 2005. So between 2001 to 2005, that is t is equal to 4 years. So you substitute it into this. So this is my calculation. And then what I'm going to get is the answer 1975.31. So they want me to differentiate with respect to t and find that. So when you're trying to differentiate an exponential, you have to use this rule over there. So we got a over there. So a in this case is 1.5. And then you write akx. So you just basically go 1.5 minus x, minus t, sorry. That's the answer. And don't forget, you have to times this all by 10,000. So we squeeze in another 10,000 right over there. And the exponential is minus t, so we have to differentiate that, and that will become -1. Because you put the k over here, which is -1, so you put -1 like so. So that will be dv by dt equals to all of this. And they say that t is equal to the number 4. You do this calculation, and you get -800 pounds. So therefore, the change is £1. So what it means is the car value is decreasing by £801 per a year. So I'm going to try question number 11. I differentiate that to x, differentiate this. So you know how to do the product rule and everything like that. So I'm not going to keep going through it. So that is that. Differentiate that, which is minus 6y dy by dx. And the rest of it is going to be 0. So you now need to expand all of this, and it gives you that. And then you factorize by dy by dx. So when you factorize that, you factorize those two, it looks like that. And you move everything else to the other side there. So this becomes minus 2x. Apologies, this should have been 2y. And this becomes minus 2y. Like so. And then what you got to do is move this to the other side. So you divide by it. So you get like that. And then you factorize by minus 1. So you put minus 1 over there. And you put the fraction, divide everything by the number 2. And divide the bottom by the number 2. And that is your answer in there. Now, they want you to find out the coordinates. So you make the gradient is 0. That's what they said. So x plus y must be equal to 0. So y is equal to minus x. Then what you're going to do is you substitute it into there, and you substitute it into there. So you get something that looks like the top over here. You simplify it over, and you get that. Move the 4x squared to the other side. So it becomes positive x squared, and just divide everything by the number 4. So x squared equals 4, x is equal to 2, and x is equal to minus 2. So I'll put 2 coordinates over there, and then you find out your y coordinate. You substitute 2 into this. So if x is 2, y is minus 2, and you substitute minus 2. So minus 2 over minus 2 is just a minus over minus 2. Minus 2 is just going to be positive 2. So question number 12, we differentiate all of this. So this is going to be 10x plus 2 times by the derivative of x. To derive xy, you just have to use the product rule. So you end up with 2 times by x dy by dx plus y. So that's done. That one will just become minus 6y. And this is just equal to 0. Or don't forget to put the dy by dx next to the minus 6y also. So tidying it up, it looks like this. We could factorize by dy by dx, which is just 2x minus the 6y. And we move everything else onto the other side, which is minus 10x, and we just divide it over. So we get something that looks like this, and we just divide everything by minus 2. So we get 5x or 3y minus x. Now we're given the coordinates of the coordinates, which is 1, 2. So we substitute the number 1 as the x coordinate right over here, right over there, and the number 2 as the y coordinates right in those positions. So when we do this calculation, we get the answer 7 over 5. And then we go back to the equation y minus y1 equals m minus x1, like so. So y minus y1, the first y coordinate is the number 2, put 7 over 5, and then x minus 1, like so. If we rearrange this and make y the subject, sorry about this actually, we're told it's the normal. So the gradient is 7 over 5, but we do minus 1 divided by 7 over 5. So this gradient is actually minus 5 over 7. So when we simplify it, it looks something like this. We times everything by the number 7. Oh, apologies, you just want it as y. So A is equal to minus 5 over 7, and B is equal to 19 over 7. You differentiate this explicitly, so this becomes 3x squared minus 2 times by the differential of it, which you use the product rule, minus the 4 over there, and this is 3y squared dy by dx equals to the number 0. You expand all of this, and then you factorize by dy by dx, and you move all of the other stuff to the right-hand side, like so, okay? And then you just divide by this also. The answer to it is seen over there, and you substitute x is equal to 4 into everywhere that says x over there, and you substitute y equals 3 into the equation. So you get something that looks like this, and the gradient is equal to minus 2. So they say the normal, so you do minus 1 divided by the gradient over there, minus 2, which is equal to a half. So we know what the gradient is. It's a half. We know what the x coordinate is. And we know what the y coordinate is, 3. So we get something that looks like that. And then if you tidy this, times everything by 2, you get 2y equals x plus 2, and move it all onto the left-hand side. Sorry, I mean, move this to the right-hand side, so you get this. And that is going to be your... So I'm going to do question 1. And then they say P and Q are integers, so they are constants. So what I'm going to do is just differentiate with respect to x for each one of these. So this one just becomes 3px squared. This one, just put the q on the bracket and then just differentiate x and y, which it becomes this. And you write it like that. And then you differentiate this also. And this is equal to the number 0. Then what you have to do is you have to expand the bracket and factorize by dy by dx. Let me just factorize by dy by dx. I got dy by dx in 2 locations. So I put qx over here, and I put 6y over there. And I'll move this to the other side. And q times by y is qy, which I'll also move to the other side. So both of those become negative, and then I'll just have to divide by that on the other side. Now, what I end up with is what you see on the left, and then I just need to plug these all in. So I write A as minus 3, B as going to be equal to minus 1, and C as going to be equal to the number 6, like so. Now, you're told that the x coordinate is minus 1, so I could substitute it there. And the y coordinate is minus 4. And I'll substitute them all over here. Actually, before that, what I'm going to do, I'm going to substitute it into this equation right over here. So I get something that looks like this. If I simplify it out, I get that. And then we're given the normal equation over there. If you rearrange that normal equation and make y the subject, you get this. And this is my gradient. So the actual tangent, okay, because this is the normal, I have to do the inverse of it. So I divide it by minus 1 to find out what the tangent gradient is going to be, which is 26 over 19. Now, I'm going to go back to my dy by dx equation for the tangent gradient. So by working out my dy by dx, which is 26 over 19, it should be equal to all of this. Now I just got to tidy up all of this over here, and it's equal to 26 over 19. I multiply it by both sides. So if I do 19 times by all of this, the 3p minus 4q, I get this. And if I do the q plus the 24 times by the 26 over there, I get that. Now, so this is minus 76q. I bring that to the other side, and I get this. And then what I'm going to do, if you remember the previous equation where I came P minus 4Q equals 22, I could see this is 57P. So I'm going to times this by 57. I'm going to times this by 57. And I'm going to times that by 57. And I get 57P minus 228Q is equal to 1,254. And what you just do is a simultaneous equation. You subtract the 2 equations, so these 2 cancel out. This minus this is going to be 126 Q. And then you just do 624 minus that, 630. So Q is just going to be 630 divided by 126, which is minus 630, I mean, which will give me minus 5. And that is my answer. Let's work out what P is. P is just going to be 22 plus 4Q. So P plus minus 20, I'm sorry, because minus 4 times like this is actually plus 20. So this is actually P plus 20 is equal to 22. Then you minus the 20. So P ends up equaling the number 2. And Q is equal to the number minus 5. So for question number 2, what we're going to do is to chain rule. So we times it by 3 at the front, x plus y. And then we have to times it by the derivative of this, which is 1 plus the derivative of that is just 1 dy by dx. And don't forget, this turns it into a squared, okay? Like so. All of this, and you're going to get, and you get this. You collect the, so you get minus 3 at the end. So you also differentiate that. So it's 6x minus 3y by dx. Then you collect in all the dy by dx on one side. So one of the dy by dx's is this, and the other dy by dx is the minus 3 dy by dx on that side, which you bring onto this side, which makes it plus 3. You leave the 6x on the other side, and you move this to the other side also. And that is that. You want dy by dx, so you're going to just divide this over, and that is what you get. And then you could also divide everything by the number 3 if you wanted to. And that is the answer you get. Okay, so now what you're going to do is you're going to have to figure out the normal. So let's figure out the gradient by substituting x equals 1 into all of this and y equals 0 into all of these parts over there. So you get something that looks like that, which is equal to a half. Now you want the normal. So you do minus 1 divided by a half, which is minus 2. So that is the gradient of the normal. So minus 2 is the gradient, and you just substitute your x values and your y values. And this is the answer you get. Answer. So prove that it does not meet. So what we're going to do, we're going to substitute y equals all of that into all of the x parts over there. So you get something like that. And when you put minus 2x plus the x over there, it just becomes minus x plus 2. So you expand all of this, it all up, and what you eventually get is x cubed minus 3x squared plus 18x minus 16. Now we know already that the two equations meet at the x coordinate of 1, okay? So we know the factor of all of this is x minus 1, okay? That's the factor. So if you factorize it by x minus 1, you could do the whole division method. I'm not going to do it over here, but plus 16, okay? And then let's try. So we know x equals 1 is a factor because we're told over here. We'll solve this equation. Now, what you notice with this equation, b squared minus 4ac is less than the number 0, okay, when you try and solve that part, the quadratic part. So it is not part of the solution.